But the goal with the problems today would be to try and see if there's a special pattern and apply the problem to the special pattern instead of just relying on foiling. Now, foiling will always work, or distributing will always work for the problem, but there are special problems that are set up in a certain way that we can try and apply a pattern to that. Last chapter, the first three that are on here, we've talked about last chapter, except we talked about factoring them instead of trying to multiply them together. And those patterns, this one would have been the perfect square binomial, where you have a squared minus b squared. And then we talked about those perfect square trinomials, where the first and the last terms are those perfect squares, but we have a trinomial in that form, like x squared plus 4x plus 4. Or there was a minus sign with it, so x squared minus 4x plus 4. The last problem of your homework assignment, problem 72. That was one of the the special patterns. So that was 9a squared minus 30a plus 25. So that was the last problem of your homework. That was a special pattern that if you factored it using the special patterns, and some of you did, 9 is a perfect square, 25 is a perfect square, so I could take the square root of 9 and get 3. It's a minus sign. Take the square root of 25 and get 5, and then that quantity is squared. And some of you were able to kind of remember that. But that's the special pattern where you're trying to factor it to break it down using the special pattern, the fact that the first and the last terms are perfect squares. So today our goal is to start with the quantity that has already been factored and kind of work backwards through it and either multiply it or apply a pattern so that we can kind of skip the multiplication process. So this would be like the shortcut instead of doing all of that multiplying. So the first one is the perfect square with the sum and difference. So we have a plus b times a minus b. And when you're given these two and you're multiplying them together, the pattern says that after you FOIL, you just end up with a squared minus b squared because the middle term ends up canceling out because of the plus or minus. So if you look at x plus 2 and x minus 2, how would that multiply together? What would that become? Virginia?
X squared minus 4.
Right. So the x is my a term. The 2 is the b term. So if I'm applying it to the pattern, it says x squared, a squared, minus b squared. Well, b squared is 2. So 2 squared. So you get x squared minus 4. Or you could FOIL them, and if you FOIL them, you still get x squared minus 4. Same.
So if it was like x plus 2 and then x minus 4.
Then they have to both be the same for it to apply to the pattern. So that's why the a and the b are there. So a and b must both be the same in the problem.
Okay.
So the next set would be the square of a binomial, whether I have a plus b or a minus b. So if there's something squared, one way that we could multiply this is just by writing it twice. That's what that means when you have a quantity squared. It means you have 2 of them. So you could write it twice and then FOIL the problem. Or we could try and apply the pattern to it. And the pattern is that a squared plus 2ab plus b squared. And again, this is that trinomial that we talked about in chapter 4. We're now just doing the reverse of it in chapter 5. So we have y plus 2 squared. So instead of writing that twice and trying to FOIL it, the y is the a term, the 4 is the b term. So I'm going to just kind of apply it to the pattern just to see how it works. So it says a squared. Well, in this case, that's y squared. And then there's a plus sign, and it says take 2 times a times b. That's how you get the middle number. Because when you're FOILing it, you're really FOIling and doubling that number because you're multiplying it once, and then you multiply it a second time. And then b squared would be 4 squared. So that's what it would look like if I apply it directly to the pattern. And then when you simplify this, we end up with y squared. 2 and 4 multiplied together make 8, and 4 squared is 16. This would have been the problem you started with in chapter 4, and you were asked to factor it to get it into the parentheses. So the 16 is a perfect square. If I factored it, it would be y plus 4 quantity squared. Questions? So with the 1 underneath, the only difference with the minus sign is that if there's a minus sign in my parentheses, that middle term has to be negative. But you're only using the values that are there, so you're not pulling like, in this case, it's just the 2 that's the b, not the minus sign. The minus sign is part of the formula. The minus sign doesn't actually go in when you're using the numbers. So if we're trying to apply this formula, a is all of that 3p squared. B is just the 2, not a negative 2. That negative is part of the formula, not part of the number, so they're not connected. Kind of like when we were doing the vertex form of the parabolas. So trying to apply this formula, it says take a squared, so that's 3p squared, but all of that is also squared. So that's what the formula says. Take whatever a is and square that quantity. It's a minus sign inside, so here's where my minus sign goes. And then take 2 times a, well a is 3p squared, and then times b. B is just positive 2, just the numerical value, not the negative with it. And then b squared would be 2, and then that's squared. So if I'm plugging the values into the formula, that's what it looks like. Again, you could FOIL that and get the same answer as well, Sam.
How come it's just the numerical value?
Because the minus sign is already applied in the formula.
Okay.
So like that minus sign is there because of the minus sign in the problem. So it's already applied to the formula. Other questions? So Kate, if we take 3p squared and then square all that, what does that make?
9p to the 4th.
So 9p to the 4th. And then if we multiply the middle terms together, what do you get?
12p squared.
Good. So 12p squared and then 2 squared is? 4. So if I wanted to go backwards and try and factor it, we'd take the square root of the last term, the square root of the first term, and that's how we could go back into that factored form. Because they're perfect squares. Questions? So the third pattern deals with the cubes. So this is now new because we didn't factor cubes last chapter because that was just everything that was x squared. So this kind of takes us into this chapter talking about polynomials that have larger powers than just the x squared. So that first one says a plus b cubed. Again, if I was writing that out, we would really write, how about a plus b? So we would really have a plus b times a plus b times a plus b. And I think you had like 3 or 4 problems not last night where you were multiplying 3 parentheses together. So if I was doing that, I would multiply 2 of them together, get that answer, and then multiply the third parenthesis through, which works. It'll work for any problem like that. However, if you can try and apply the pattern, instead of doing all that multiplication, you're really just basing it on the pattern instead of actually multiplying the numbers together. So that pattern, if you had Mr. Warnock last year, is actually Pascal's triangle applied to those factoring problems. If you didn't have him last year, you probably don't know what Pascal's triangle is, and that's fine. So it's okay, but the pattern says it's the first term a cubed, and then there's a 3 here because we have 3 parentheses. You're distributing it through like really 3 times. So there's that 3a squared b. The next one says 3ab squared. The last one is b cubed. Notice like it is a pattern. Your a's start out with a cubed and they go down to then nothing at the end. So we have a cubed, a squared, a, and then the a isn't there anymore. The b's start the same way except there isn't a b, and then the b powers increase to get to the last term. So that pattern that you have there, the a's decrease, start with the largest power of a, decrease down. Your b's, you don't start with a b, and you increase the powers up. So trying to apply that to the pattern. So a is x, b is 1. So I'm taking x cubed, 3 times x squared times b, which is 1. And then 3 times x times b squared, and then finally b cubed. So I'm just literally taking the x or the 1 and applying it into the pattern, replacing the numbers a or the letters a and b with whatever values we have. So Jenna, if we simplify this, what does it become then?
X cubed plus
3x squared. Okay.
plus 3x
Just 3x, because this guy is just an x.
plus 3x
And then 1 cubed is just 1. Yeah. So we have x cubed plus 3x squared plus 3x and then plus So the next one has a minus sign in it. Notice that the minus sign alternates. So it starts with a minus because there's a minus in the problem. It changes to a plus, and then it goes back to a minus sign at the end. Because that value, if I'm multiplying three negatives together, it still remains a negative number. So here's my A, there's the B. I'm going to try and apply it to the pattern again. So A is R, so that would be R cubed. There's a minus sign in the parentheses, so it starts out with a minus sign. And it's minus 3 times A squared, and then times B. B is 3 as well. Then there's a plus sign, and it says take 3 times A, which is R, times B squared, so B squared would be 3 squared. And then last, subtract. You're subtracting B cubed, or I'm subtracting 3 cubed. So when you're looking at your homework tonight, it'll be essential for you to have this paper out next to your homework so that when you see the problem, you can kind of attach it to the pattern. So is it, we have R cubed, that starts out here, and then what?
Minus, would we have minus 9r squared?
Good. And then the next one, you have 3 squared times 3.
Oh, 9r squared. Wait, no.
What's 3 squared? Start with the squared part.
Oh, 9.
Times 3 is,
27
there you go,
r
so
squared.
27. And
Right.
then negative 3 squared, so 3 times 3 times 3.
27.
Yeah, 27, nice. So again, the powers should go down as you work through. Your variable in the front should decrease. R cubed, R squared, R, and then there shouldn't be a number. It should just be a number. So if you look underneath at those 3 problems, each one of those goes from pretty much the 3 different types of patterns. So the first problem is a sum and difference. The second one is the binomial. The third one would be, the square of a binomial. The third one is the cube of the binomial. But each one of these apply to those patterns. So see if you can try and use the pattern. So the first one would be a squared minus b squared. The second one is a squared, 2ab, b squared. And then the last one is that cube. So that's a cubed. There's a minus sign. So try and apply the patterns to those 3 problems. Try and use the patterns instead of relying on like doing all the foiling. It really will save your work. It's just unfortunately remembering those patterns. Alright, Sarah, we have 7m minus 3, 7m plus 3. So what did you get for
49m squared minus
good? So you're taking the 7m, squaring that, and the 3 and squaring it. So 7m squared becomes 49m squared minus 9. So the second one, we have this binomial that's squared. So a is 4t cubed. All of that represents a. B is just 6. So if we're plugging it in, we're taking 4t cubed, that's squared, 2 times 4t cubed, and times 6, because it's 2 times a and b. And then b squared, or 6 squared. So Maddie Z, what do we have if we have 4t cubed and that's squared?
I have 16t to 6.
Perfect. And then the middle terms, if we multiply all that together, what do we get?
48t
Good.
plus 36.
Awesome, plus 36, nice. So the third one, we have a cube of a binomial. So xy is your a term, 4 is your b term. So we're cubing that xy. That stays together. All of that represents a. Then you're subtracting 3 times a, which is squared, and then times b. You're adding 3 times a and b squared, and then you're subtracting b cubed. So Sam, if we have xy, all of that's cubed, what does that become?
X cubed, Y cubed.
Good.
And then you have minus 3x squared, y squared. Is that right?
You're so
Or is
close.
it 9?
What's 3 times 4?
Oh, I forgot there's that 4 there.
Yeah.
Negative 12.
Right, 12, good. And then the next one would be 4 squared times 3.
48.
Awesome.
Yeah, 48.
And then what is 4 cubed?
16. Or cube.
Run,
64.
64. Questions?
Oh.
So there are 4 more practice problems on the top of the next page. 2 of them are the old problems that we did yesterday. So if you look at number 1, exactly like the problem we did yesterday, yes.
Can I just write that, please?
Yep, sorry. So the first one, you're using really distributing. You're distributing the x through the back parentheses. You're distributing the 2 through the back parentheses. Number 2, you're multiplying, foiling 2 of them together at the same time. You can't use a special pattern if there are different numbers in there. And then 3 and 4, try and apply the pattern to it. Yes, you could write them 3 times and foil it, but really try and apply the pattern to the problem. So again, the first one, you're really using the distributive property. You're taking x through, you're taking the negative 2 through. So for number 1, you should end up with 6x cubed minus 9x squared minus 11x plus 10. The second one, I always like foil my last 2 terms together first. You don't have to. If you use the first 2, that's fine. Your end answer is going to be the same. It's just the work in the middle will not look quite the same. But you should still end up with x cubed plus 2x squared minus 33x and then minus 90. Are there questions or 1 or 2? So then 3 and 4 are applying the pattern. This one is a plus inside and it's a cube. So my A's need to decrease. The B's are the ones that increase. And it's all positive. And then the second one is a square. There's a minus sign in there. The A still decreases, the B increases. That happens with all of these. Even if I had a power of 4, it would still have the same pattern. So Paige, if we plug in the x and the 2, what would it look like?
X cubed plus 3x squared times 2 plus 3 times x b squared plus 2 cubed.
2 cubed. So 3 times 2 makes 6. 2 squared times 3 is?
24x. Yes, no, maybe.
What's 2 squared?
Oh, 8. Oh no, 4. I thought it was cubed.
4 times 3.
12x.
There we go. And then 2 cubed is
8.
8. There you go. Perfect. And then the last one here, we have 2x squared minus 3y. Anybody have this one done? Caitlin? What does it look like if we just put the 2x squared and the 3y into the pattern?
2x squared minus 2 times 2x squared times 3y
Good.
plus 3y squared.
So 2x squared, all of that squared is,
4x to the third.
and then your middle terms, 4 times 3 is 12. And then we have an x squared and a y. And then 3y quantity squared is
9y squared.
Any questions? We're not going to do the word problem. It's actually not a very hard problem. You're just multiplying those two quantities together. So it's tedious because of all the decimals.
Oh my lord. Resource cap.
There's extras. That's all right. I'll put them on. I need to. My clock keeps going slow. You're doing 5 to 20. All of 5 to 20. Please put the multiplying ones where it says find the product on a separate piece of paper, or the space on the back. The answers are also on the back. So there should be space in the back where you could do those multiplying problems. Have an awesome day. Factoring tomorrow. There, the homework's in the book.